All right, so we are going to solve these addition and subtraction, basically compound angle trig identities. So I typically want to work with the side that has the double angle equation. So I'm going to work with the right side for this one, make it match with the left side. I'll start by converting sine x plus y into sine x cos y plus cos x sine y. Okay, and then what I notice is these two are the same and this is a 1. So I want to just split my denominator. And then these two just cancel and you're left with 1. And then cos x over sine x is just cot x. And sine y over cos y is just tan y. And now we have the other side. So our solution is complete. Let's go to the second problem. Sine x minus tan y cos x equals sine x minus y over cos y. So this one's pretty similar. The right side has a compound angle, so I'm going to use my compound angle equation to simplify this. So it's going to become sine x cos y minus cos x sine y divided by cos y. And again, here I want to just split my denominator. That's sine x cos y over cos y minus cos x sine y over cos y. And now here the cos y's can just cancel, so I'm just left with sine x. And over here, sine y over cos y is just tan y. Now if I compare this, this is basically the same as the other side. Let's go to the third question. This one's a bit more difficult. So I have cos x plus y times cos y plus sine x plus y times sine y equals cos x. So in this one, I'm going to work with the left side. It's obviously more complicated. I'll start by getting rid of my addition subtraction equations. So this is just cos x cos y minus sine x sine y. You want to keep this in the bracket. This is all times cos y. I'll put that in a bracket as well. And here I'll convert sine x plus y into sine x cos y plus cos x sine y. Again, this is all inside a bracket and it's multiplying by sine y. Now I want to distribute these into the brackets. I'll keep a bracket there as well. I want to distribute this by multiplying it by both terms. So this is going to become cos x cos square y minus sine x sine y cos y. And this is going to become plus sine x. I'm multiplying the sine y into this bracket. So sine x sine y cos y plus cos x sine squared y. Now what I notice is the two middle terms are identical, but the signs are the opposite. These are going to cancel each other out, and I'm just left with cos x cos square y plus cos x sine squared y. And now if I common factor out a cos x, I'm left with cos square y plus sine square y. And I know that cos square y plus sine square y is just 1, and cos x times 1 is just cos x. Last question. I have sine x plus y times sine x minus y equals cos square y minus cos square x. So again, here the left side is more complicated. I want to work with the left side. So I'm going to make these into my double angle formula and my compound angle formulas. That's sine x cos y plus cos x sine y. And this is all multiplied by sine x cos y minus cos x sine y. Next, I want to FOIL out these two brackets. So I'll do the first term times the first. So that's just sine square x cos square y. I'll do the first times the last. So minus sine x sine y cos x cos y. I'll write it all in order with sines first and then coses. It makes things a bit easier. Next, I'll multiply the two internal terms. And that's going to be plus sine x sine y cos x cos y. And then I'll multiply the last two terms. I'll squeeze that in below here. That's just going to be cos square x sine squared y. Okay, the next thing I notice is that the two middle terms are identical but opposite signs. So these two cancel. I'm just left with sine square x cos square y minus cos square x sine squared y. Now I want to make this the same as this over here, cos square y minus cos square x. This is almost the same. What I can do over here is I can change my sine squared. Well, I can do difference of squares here. But would I want to do that? That would actually take me backwards to the question. So you definitely don't want to do difference of squares. So you want to kind of get rid of a few things here. So I'm going to get rid. I look at here, I have cos square y, which is cos square y. So I want to get rid of sine squared x. So I'm going to turn sine squared x to 1 minus cos square x using my Pythagorean identity times cos square y. And over here, I have cos square x. So I want to keep my cos square x the same. I want to turn sine square y into 1 minus cos square y. So this is going to get it a bit closer to this solution. Now I want to expand and multiply out these brackets. So cos square y times 1 is just cos square y. This is cos square x cos square y. Then negative cos square x times 1 is just negative cos square x. Negative cos square x times negative cos square y is just positive cos square x cos square y. Now you notice these two terms are identical, but they have the opposite signs. So these two cancel, and then you're just left with the final solution, which is cos square y minus cos square x.